All right, so I've been spending a little bit of time working on my little side project, SaaS, whatever this is, and I redesigned the homepage. And I was also kind of like looking through my code and looking for areas that I could potentially refactor. And one thing I came across was on the back end, I realized that users could potentially spend more credits than they actually bought. I want to walk you through like how did I fix that and what was the actual issue. And it ends up being I use transactions that basically prevent users from using more credits than they actually have. So what I'm going to do is I'm going to go and show you the get diff. So on the left here, this is how the code used to look, and on the right is how I changed it to be. So let's talk about the issue, right? When you're building out a backend API, sometimes you don't want to allow a user to do something unless they have enough credits. In this particular example with this app, right? So when a user hits this API endpoint, they are basically saying how many images they want to generate. And then I fetch the users over here. I fetch the user by their ID. And then I check, does this user have enough credits to basically create that many images? Okay, so for example, on the UI, if you were to type in, I want to make 10 images, I check on the back end and say, hey, does this user have 10 credits? And if they don't, I throw an error. And this seems like it works, but it's actually a very naive approach. Taking a step back, how does this actually work? Why is this a problem? So imagine that this is deployed to Lambda, and Lambda will auto scale based on the request. So if you were to hit your API endpoint 100 times, that basically is going to potentially spin up 100 lambdas all executing in parallel. Now, when all those lambdas run through the code, they're going to get to this line and they're all going to try to fetch the latest state of the user, which happens to have credits of, let's say, 1. Okay. Now, if that user were to do 100 requests and say, I want to create 100 images, but they only have 1 credit, potentially this if statement is going to pass on like a lot of those lambdas, even though one of them is end up going to decrement the credits. Some of them are actually going to not get the full accurate state of the credits, and you're going to basically allow users to use more credits than they have paid for. So the solution to kind of preventing users from using more credits than they have paid for is by using something called a transaction. So this is like a SQL type of thing that you can do to basically make sure that when you try to spend money or spend credits, and for whatever reason, the person trying to spend that money has gone under 0, the transaction is going to roll back that change. So let me just kind of walk you through what's going on. So in this code, I basically say, hey, I want to make a transaction. And this transaction is going to decrement the number of credits that the user has. So in our case, they're going to decrement by 1. And if the credits is less than 0, then this transaction is going to roll back. And by rolling it back, it means it's basically going to increment the credits back up to whatever amount they're trying to spend. So if they're coming in here and they want to generate 1 icon, we decrement their credits by 1. We make sure that they have greater than or equal to 0 credits left. And then we will throw an error saying not enough credits if they've used more credits than they should have. Now that I think about it, I don't even know if I really truly need a transaction. It really depends on the database you're using and how it kind of applies to the ACID acronym, like how consistent is it? So if 2 lambdas try to decrement the credits by 1, are we guaranteed some type of like consistency, or is this backend database actually eventually consistent? So I am using Prisma, and I'm not 100% sure, and I have to look into their docs to see if they are eventually consistent or if they are consistent, because this transaction might actually be, now that I look at it, not even important. But regardless, you can use transactions if you ever need to verify that like a certain set of changes in your data have to all update in unison. And if any of those were to potentially not work, you can roll back the whole set. So imagine it's kind of more useful for you, like you're sending money to someone's account. So you need to decrement some money from one person's account, and then you need to increment money in another person's account. But if any of those things were to potentially break, you just roll it all back and the transaction fails, and you can kind of do some special logic based on that failure scenario. So by the way, if you're watching this and you can point me to like, Cody, you don't even really need a transaction here, I would appreciate that. Leave a comment and teach me the proper way to do this. Other than that, I guess the point of this video was just like, make sure you're considering the possibilities of like what happens when a mischievous or a malicious user is trying to use your API service and just abuse it. Is your API going to handle the requests that they're making, or is it going to just, some issues are going to fall through the cracks because of the way you have the code structured? Another thing I want to point out is I used to update and decrement the credits after I did the Dolly API request. So again, like if someone were to hit my API with 100 requests at the same time, I'm going to get charged for 100 different dolly requests, which are all going to generate images and charge me money. And then I would decrement that user's credits. And eventually, I think this user would get down to like negative credits, which would be like, a really big issue. So again, like just moving the check to be before we try to hit the dolly API. Obviously, you should probably want to do that because you don't want to be charged for requests and then like decrement the user's credits. And this thing also is kind of slow, right? Hitting the dolly API takes like 5 seconds. So again, if someone just flooded my API, that's enough time for them to hit with a bunch of different requests until they actually start decrementing the credits. So decrement the credits first, use a transaction if you need to, and then give them access to hit the thing that's going to cost you money. Anyway, hope that was an interesting little topic to talk about. We could probably dive more into like the ACID acronym of databases and consistency versus eventually consistent. I know that I work in DynamoDB on my day job, and a lot of the data there is eventually consistent and they have transaction support, but you'll start seeing issues with multiple people trying to modify the same record, and bad things will happen. Like this record will get into bad states because two people tried to modify it at the same time. So understanding like optimistic locking and pessimistic locking is really important, and understanding transactions is very important to make sure that like if you have a piece of data, for example, like let's say you had an application where you're managing schools and classrooms and you have a bunch of different students all trying to modify something that's shared in the classroom. You want to make sure that one user cannot like overwrite an existing user's request. Or I guess a better example would be like you have a principal and a teacher, they both have access to a classroom, and one tries to update a student's name while the other one tries to delete the student. Is your code resilient enough where it won't just cause strange issues in your data? And typically what you want to do is make sure that your transactions are set up properly in the case that two people try to modify the same data at the same time, or add some type of locks to prevent that from kind of messing up your data. Anyway, that's all I really wanted to talk about. I've been fighting a cold, my voice is going, so I'm going to wrap this up. If you have any questions, feel free to talk to me on Discord. And by the way, I do plan to make a course to kind of walk you through how I built this little SaaS product. We'll talk about Stripe, we'll talk about hosting this thing on Amazon, we'll talk about using the T3 stack to build this out. So if you are interested in seeing a course in the future, be sure to subscribe to my newsletter, which is in the description below. And when I get around to making that, I will send out an email and let you guys know. All right, have a good day and happy coding.